From the first law of thermodynamics, dq equals to d plus dw, where dq equals to heat transfer, d equals to change in internal energy, and dw equals to work transfer. Since the gas is enclosed in a vessel volume, whose volume is constant, hence dv equals to 0. This implies dw equals to pdv equals to 0. Hence dq equals to d. Now d equals to ncv t2 minus t1 from the formula of root mean square velocity. We have Vrms equals to 3 under root 3 r3 by m. So v2r by v1r equals to under root t2 by t1. This implies t2 by t1 equals to under bracket v2r by v1r to the whole square. This implies t2 by t1 equals to eta square. This implies t2 equals to eta square t1. Now from t equals to ncv t2 minus t1, ncv eta square minus 1 t1, m by m dot cv under bracket eta square minus 1 into t1 equals to m by m dot under bracket r by gamma minus 1 under bracket eta square minus 1 t1. So we get finally d equals to 1 by 2 eta square minus 1 into I mrt by m, where I is the degree of freedom, number of degree of freedom. Putting all the values, we get d equals to 10 kilojoules in proper unit. The temperature of a gas consisting of rigid diatomic molecule T is equal to 300 Kelvin. Calculate the angular root mean square velocity rotating molecule. Of rotating molecule, its moment of inertia is equal to I equals to 2.1 into 10 to the power minus 39 gram cm square. Solution: we know that v equals to omega r from circular motion, that is v rms equal to omega rms into r. Now the moment of inertia of a diatomic molecule can be calculated as I equals to 1 by 3 mr square plus 1 by 3 mr square equals to 2 by 3 mr square. Hence r equals to under root 3 I by 2m. Equation 1. From equation 1, Vrms equals to omega rms into under root 3 I by 2m. Now we do know that Vrms equals to under root 3 kt by m under root 3 rt by m. Hence under root 3 kt by m equal to under root 3 I by 2m into omega rms. This implies omega rms equals to under root 2 kt by a. Putting all the values, we get omega rms equals to 6.3 into 10 to the power 12 radian per second. A gas consisting of rigid diatomic molecules was initially under standard conditions. Then the gas was compressed adiabatically. Eta equals to 5 times. Find the mean kinetic energy of a rotating molecule in the final state. Let T1 and T2 be the initial and final temperature before and after the compression. This implies T1 equals to T naught equals 270 degree 0 Kelvin. When it is compressed, eta equals to 5 times. This implies V2 equals to V1 by eta. Now V1 to the power gamma equals to P2 V2 to the power gamma, or T2 by T1 equals to under bracket V1 by V2 to the power gamma minus 1, since PV equals to nRT. This or equals to eta to the power gamma minus 1 equals to eta to the power 2 by I. Hence mean kinetic energy per degree of freedom at temperature T2 is